All right, so we're going to continue our conversation of scientific notation, and this is the toolkit entry that you have in your toolkit. It says, scientific notation is a way of writing very large and very small numbers compactly. So that is the definition of scientific notation. It says a number is said to be in scientific notation when it is written as a product of two factors, okay? And it must follow this criteria. The first factor is less than 10, and the second, but greater than 1, okay? The second factor has to be a base of 10. So that's where your product comes into play. And the factors are separated by multiplication, okay? So I took some of the values out of this chart so that we could fill it in, okay? But I first want to review what we looked at last week, okay? So we looked at something like 5 and 32 hundredths times 10 to the 6th. That 6 is a positive exponent, which means my number should get larger. Hopefully you filled that in. So I'm going to be moving the decimal. How many place values? 6. And if our number is going to get larger, it's going to go to the right. So it's starting here, and we're going 1, 2, 3. I didn't want it to do that. 1, 2, 3, 4, 5, 6, which means I need to add 4 zeros, and now my decimal point is at the end. Now, the example they're giving us is not to the power of 6. The example they're giving us is 5.32 times 10 to the negative 6th power. Okay, so let's take a look at what happens here. We looked at this last week. Because it's a negative power, it's going to get smaller. So we have 5.32 decimal points here. It's going to go to the left, right? And if I move it 1 here, I need to now move it 5 more. So what does that mean? I have 1, 2, 3, 4, 5 zeros, 5, 3, 2, and the decimal points out in front. So you could double check it. Does it really work? 1, 2, 3, 4, 5, 6, it works. Now, how many people know how to read that number? What place value is that 2 in? Well, we could figure it out, but most people don't know how to read that number accurately, which is why we write it in scientific notation, because we can read 5 and 32 hundredths times 10 to the negative 6th. We know what that value is, all right? So now, today, we're going to take a look at going the other direction. So this was scientific notation into standard form. Now we're going to look at standard form values. So we're looking at this example here, okay? And we have I probably should have inserted another page, but I didn't. All right, so I have 0.000307. And I want to put it into scientific notation. So I need a number that's between 1 and 10. So I'm going to move my decimal point until I have that. Okay? 1, 2, 3, 4 is where it's going to go. So I'm going to have 3.07. Is 3 between 1 and 10? Yes. Times base 10. And this was a decimal, so my exponent is going to be negative. And I moved it 1, 2, 3, 4 spots. So it's going to be negative 4. Okay? The next one, I have no idea how many zeros are in that. 14 zeros. So here's our example. You should be writing this, by the way. All right, so I now want to change this into scientific notation because I don't even know how to read this value. I'd have to look up the place values on the internet to be able to read you this number. Okay, so we're going to be moving this decimal so that it's between the 2 and the 6, because 2.61 is between 1 and 10. So this is times 10. And how many place values did I have to move that decimal? So we're going to count, right? I'm just going to count zeros. That's 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14 place values to there. So 15 to there. It is a decimal, so it would be to the negative 15th power. All right, we're going to be looking at a worksheet today. Let's look at a couple examples together. So the first one is 625. Well, we do know how to read that number, but they want us to express it in scientific notation. So if my decimal point's behind the 5, and I want to make it so that it's between the 6 and the 2, I would get this times 10 to the, what do you think? How many decimal places did I have to move that? So from the end here, 1, 2. So it'd be times 10 to the second power. Let's look at another one. Let's look at number 3. Where is that decimal place? It's at the end of the number. If I move it here, do I have a number between 1 and 10? Nope. If I move it here, do I have a number between 1 and 10? Nope. If I move it here, I have 49.603. Still not a number between 1 and 10. But if I move it there, I get 4.9, and that is a number between 1 and 10. So it would be 4.9603 times 10. And how many place values do we have to move it? 1, 2, 3, 4. Times 10 to the 4th power. Okay, let's look at number 5. My decimal point right now is here. And I'm hoping you're able to look at this and be like, well, it needs to be there. So I have 1.8569 times 10. And how many place values was that? 1, 2, 3, 4. Okay. So those were all examples of numbers greater than 1. Right? Those were all not decimals, so they all had positive powers. Okay? I think all of these will have positive powers on this worksheet. Okay? The answer key is provided, so you can check your work when you're done. Please try not to cheat and use it and just copy the answers down, because that's not going to benefit you. You will have a quiz coming up.